So mostly I'm doing on this particular playlist videos about collapse, but there's reasons for the collapse, and one of the reasons is climate change. I had a friend recently ask me about global warming and why they don't call it global warming anymore, why they call it climate change, and asked me to explain it in a way that was very simple and easy to understand. So I said, I'll make it a video. So the large cycles that happen on the Earth, they're all part of what's called the Milankovitch cycle. I'm not going to get too deep into like the science of it, but it has to do with the Earth orbiting the sun, how circular the orbit is. Sometimes it gets a little more oblong, a little more egg-shaped. The planet itself spins on its axis, but it leans a little bit more sometimes, and then it wobbles back up like a top. There's a few different parameters of this cycle that all kind of band together, and sometimes they all lean in a certain way and the planet gets a little bit warmer. Sometimes they all lean in another way and the planet gets a little bit cooler. These are glacial and interglacial periods. Glacial periods last, somewhere around 100,000 years. It varies quite a bit. That's when glaciers creep down from the poles, and from the poles to the north they creep down, and from the south they creep up. They are, where I live in Seattle, during a glacial period would have ice above where I am right now. These periods last a fairly long time, and in between them, all of those different cycles, all of those different parts of the Milankovitch cycle come together to warm up the planet. And it's not just a matter of kind of a round up and down. It's going from a state where there's a lot of ice on the Earth to a state where there's not as much ice on the Earth. It kind of goes up, and then it transitions very quickly into this upper state. What's happening now is human-caused CO2 being put in the atmosphere. Not only CO2, but things like methane also. There's other gases involved, but those are the two main culprits. You have methane, which is CH4, and carbon dioxide, which is CO2. They're both considered greenhouse gases. Now, the special thing about greenhouse gases is you can see I'm in a car that it has a dark interior. In the winter, if I park my car in the sunlight, if it's sunny and 30 degrees, it's freezing, I get in my car, it's pretty warm. It could be like 50 degrees or more. If I'm in the summer, my car parked in a parking lot, it might be 90 degrees out. It can just be a face melting 130 or more in my car because my interior is absorbing sunlight. Being dark, it absorbs it more efficiently and then radiates it as heat. And the windows keep that heat in. They're not very good insulation, but they're just enough that heat builds up in the car over time. The Earth is doing the same thing because these gases are the same. Sunlight goes through carbon dioxide really easily. No problem. Sunlight goes through it all day long. It's basically invisible. Infrared, however, does not. It hinders it slightly. So the sunlight goes through the atmosphere, hits the ground, warms the ground, heat builds up, and it can't radiate into space as easily because there are greenhouse gases that are now blanketing the world in a way. It's as if you just added a layer of insulation that only works one way, that only works with heat and not light. One of the reason why they stopped calling it global warming is while the Earth is warming and has warmed 1.5 degrees in the last 70 or so years, it has gotten warmer, but that's warmer on average overall. Some places can still get colder. They can still get cold. We had that idiot senator, or I can't remember if he's in the House or the Senate, bring a snowball onto the floor of Congress to prove that climate change wasn't real. It's still going to snow, even if it gets warmer. Like, that is an absolutely ridiculous thing. And even now, as we're faced with very large snowstorms and cold that is blowing trees up, even though it's gotten so cold, the planet overall is getting warmer. One of the reasons why this happens is normally everybody knows the equator is nice and warm. That's where all the tropics are. It's where a lot of the deserts are. And then the farther north you get, eventually you get to the poles and they're very cold, because the equator or anywhere in the middle tropics, the sun's hitting at basically 90 degrees. It's catching the full sun and having to go through very little atmosphere, warming the ground efficiently, and it becomes warmer. As you get up towards the poles, you're going through a lot of the atmosphere. You're going through much, much, much more atmosphere, and you're hitting the ground at an angle, so you're catching less light, you're warming less, so the poles are naturally colder. Now, since we're warming overall, the poles warm more quickly than the equator does, because as you warm, the poles just can continue to absorb it because you have all that ice. As the ice melts, it exposes more sea, which is dark and can absorb more, and it melts more ice. So it's kind of a cycle. Once you get into it, we don't know where the top is. We don't know. We know that there's a glacial and there's an interglacial. We don't know if there's another place where you come to a natural resting place for climate overall. If there's a place where it starts to settle into into some new version of climate on Earth. The problem comes when, as the poles warm, there's less difference between the poles and the equator, which means the jet stream, which is normally kind of runs in a circle around the Arctic, having a lot of difference keeps the jet stream very stable. It keeps it in that track. It just does a racetrack around the Arctic. As the poles warm and there's less difference, the jet stream starts to wander, and it'll go up and down, and you'll see these wavy patterns a lot more. Once it starts to wander, you can have the air mass at the Arctic, all of that really cold air, can start to wobble. And that's when you get things like the polar vortex, a term that most people hadn't heard a lot before. You hear it more now because all of that cold air mass will wander around and sometimes settle, like it is now, above a lot of the US. So an incredibly cold air mass that is parked over a place that isn't used to cold. And that is one of the things that they're afraid of. As the planet warms, everything starts to become more energetic, which means things start to become less predictable. You have less times when it's raining, but when it rains more. You have the ability to hold more water in the atmosphere, and so you potentially have these rainstorms that, like in Houston, they had one where a hurricane just dumped for days because it had so much ability to hold on to moisture. We are entering a different climate than what most human history has been used to. So the rise of society was dependent on knowing when to plant things. Droughts were few and far between in a lot of places. And once you start losing that, once you start having droughts become more common, you have floods becoming more common, all these things that you used to see on the news, you'd see them every now and then, seem like they're almost a yearly thing somewhere. It is getting more and more wild, and that makes farming difficult. It makes it hard to plan. It makes crop failures more likely. And that is something that a very complex society of 8 billion people can't really deal with very well, much less 10 billion people or more complex societies, and they're even more dependent on all of those farmlands. So that is why we call climate change what we do and not global warming, because global warming doesn't fully convey the problem. The problem is the climate is changing, and we are not equipped to deal with that, or at least we don't seem interested in dealing with it. And we don't seem interested in stopping it, at least in this country. So that is why we call it climate change. That's why we don't call it global warming, because idiots take advantage of that and pretend like they don't know the difference. So that is in a nutshell. I'll see you in the next video.